So this is going to be the first video in a new topic, SC14. And the name of this topic is actually Quantitative Analysis, not Qualitative Analysis, like I wrote on the front of your booklets. So in chemistry, you've got two different types of analysis. If it's qualitative, you've got like an unknown solution and you run tests to find out what chemicals are present. If it's quantitative, you're trying to find out the amount of those chemicals or the quantity of those chemicals present. And quantitative analysis involves calculations. So this is another calculations topic that builds on from CC9, the topic that we did on moles. It's a paper one only topic, and because it's got the code SC, that tells you that it comes up on the triple paper, but not on the combined. So when I use CC, that tells you that it comes up on the triple and the combined, because the CC is combined chemistry. When I use SC as a code, that means it's triple only. The SC stands for separate chemistry. Hopefully you'll recognize the image below. So you came across it when you looked at acids back in CC8. It's a titration, and we're going to see later on why I've chosen that particular image for the front of the booklet. So you should have been given these booklets on Wednesday. If you weren't in on Wednesday, there should be spares at the back of N17. So make sure you've got one of these booklets. You're going to need it over the next few lessons. So the first thing we're going to look at is called percentage yield, and apologies that I don't have a printed copy of this booklet. I'm going to have to work off my iPad, which is probably going to be a little bit annoying. But yeah, we're going to look at percentage yield, and this comes or builds really nicely from what we looked at in CC9. So you'll notice the same table below that we were using in CC9. So it's just going to be like a bit of revision. If we look at the sentence I've written at the top, we use mole calculations to predict the mass of a product that we should get in a reaction. So if we look straight away at the worked example, predict the mass of water that is produced when 50 grams of oxygen is reacted with hydrogen. So if you start off with 50 grams of oxygen and you react it with hydrogen, how much water should you produce? And when we work out the answer, that's going to be our theoretical yield. It's the amount of water we should produce in theory if we're starting off with 50 grams of oxygen and we have enough hydrogen. So to calculate the theoretical yield, we just use the same mole table that we were using in the previous topic. I've introduced this new word theoretical yield that we didn't have in CC9, but the process is going to be exactly the same. So I'm given information about water, so I put water in my table. I'm asked about water, so I put water in my table. I'm given information about oxygen, so I put oxygen in my table. Then I've got mass, formula, mass, moles, and ratio, just like I always do. 50 grams of oxygen, again, that's given in the question. I find the formula mass of oxygen using my relative atomic masses. I can also find the formula mass of H2O. So I've got 2 hydrogens, 1 oxygen, formula mass of 18. Remember, you're not going to use the big numbers calculating formula mass, so you're not going to be multiplying that by 2. When you've got mass and formula mass, you can find moles by doing mass divided by formula mass. So I can do that for oxygen. 50 divided by 32 equals 1.5625. I can't do that for H2O because I don't have the mass. What I do have, though, is a balanced chemical equation, and I can use that to work out the ratios. So there is no number in front of oxygen, which means the ratio is just 1. There is a large number 2 in front of H2O, which means the ratio is 2. That means that if I had 1 mole of oxygen, I would produce 2 moles of H2O. If I had 5 moles of oxygen, I'd produce 10 moles of H2O. So you're always going to be producing twice the amount. I don't have 1 moles of oxygen, however, I have got 1.5625 moles, which means I need to multiply that by 2. And when I do, I realize that I produce 3.125 moles of water. Now I know the moles of water, I know the formula mass of water. To find out my theoretical yield, it's moles times formula mass, and that equals 56.25 grams. So This is exactly the same as what we've done before. We've just got this new term, theoretical yield. This is the amount of water that I should produce in theory, provided I do have enough hydrogen if I start with 50 grams of oxygen. So I'm going to get you to calculate the theoretical yield yourself in the next example. So again, I've started it off for you, but press pause and fill in the rest of the table for yourself. Okay, so you should have ended up with an answer of 320 tons, okay? So if you're starting off with 68 tons of ammonia, ammonia is here, NH3, in this reaction, you should produce 320 tons of ammonium nitrate. That's your theoretical yield, the amount you should produce in theory. And again, to calculate that theoretical yield, you're just using the moles table exactly as we did in CC9. So for your classwork next week, I'm going to ask you to complete these practice questions to find the theoretical yield. You're going to draw your moles table exactly as we have done before, and to check your answers you'll go to page 41 and you'll be able to check the answers as you go along. So just practice doing those 3 questions to remind yourself of using that moles table. In each case, when you get your answer, that's going to be your theoretical yield that you are calculating. However, if you were to carry out one of these experiments, in general, you don't end up getting as much as what you have predicted. So let's just go back to this example. We should be getting 320 tons if we start off with 68 tons of ammonia, but if you did this experiment, in reality, you would not get 320 tons. And the reason you wouldn't end up with 320 tons is that, a couple of things can go wrong along the way. So for example, you might not have completed your reaction. You might have stopped the reaction too soon and it might not be complete. If you stop it too soon, you're not going to get your theoretical yield. You may also lose some of your product when you transfer from one container to another. So some reactions have multiple steps. You might have to transfer your product to another container and you might lose some along the way. That means you're not going to get your full theoretical yield. You may also have unwanted side reactions. So you're predicting that your 2 chemicals will react in a certain way to produce one particular product. However, you might get some side reactions occurring and they might be able to react in a different way to produce a different product. And that's typically true when you've got larger and much larger chemicals than what we've ever dealt with at GCSE, where these side reactions can become a problem. So in general, you never end up with as much as you predict that you are going to end up with. And the amount that you do end up with is called your actual yield. That's the amount that you actually get after doing the experiment. And to find your actual yield, you'll just get the mass using a mass balance after the experiment. So if you were doing this particular experiment, at the end, you would get the mass of your ammonium nitrate just using a mass balance, and you would probably find that it's quite a lot less than 320 tons. And that's going to be your actual yield. And then what we're doing is we want to calculate your percentage yield. And to do that, you're going to take the actual yield, which is the amount that you actually get doing the experiment, that you find, you get the mass of your product at the end is what you actually get, and you divide it by the amount that you should get, your theoretical yield, and then you multiply it by 100, and that's your percentage yield. Actual divided by theoretical multiplied by 100. So I've given you this table here, where I've given you the actual and I've given you the theoretical, and I want you to find the percentage yield yourself. So if I were to do the first one for you, it's just going to be 40 over 55 multiplied by 100, and then you fill in your percentage yield. And the only thing to look out for when completing these tables is that you've got the same units for your actual and theoretical yield. So for the first for the first 2, that's fine. But then on number 3, I've got grams and I've got kilograms. So it doesn't matter which way you do it. You can either go from grams to kilograms and have everything in kilograms, or you could convert your theoretical yield into grams so that everything's in grams. As long as you're using the same unit for both, you're fine. Okay, so just to remind you, if you wanted to go from grams to kilograms, you would be dividing by 1,000. And if you wanted to go from kilograms to grams, you would be multiplying by 1,000. Just make sure they are in the same units before calculating your percentage yield. The other table I've included here is more just kind of for your math skills, but it's not specifically required for you to be able to do those calculations, but just have a go at them for yourself. And then in class, you are then going to be told to complete the following practice questions. So they're all done exactly the same way, okay? The first thing you need to do is calculate your theoretical yield using your moles table. And then the second part, you're given your actual yield. So you're given the actual yield here is 12. So you'll have your actual yield and you'll divide that by your answer for 1A, which is your theoretical, and you'll multiply by 100. For number 3, you'll work out your theoretical yield in 3A. And then in 4, you see your actual is 3 grams. You divide it by the theoretical, and again, you multiply it by 100. So you'll be doing all of those practice questions in the lesson. Again, the answers for all of those questions start on page 41. So after you've done the questions, make sure you are marking your work. Any questions on any of this, just let me know. It is exactly the same as what we did in CC9. You've just got this added little bit at the end where you calculate a percentage.